Okay, Abby, here's what I did on this math problem. I'm not sure if it's right, but we'll try this. I started with the equation, the 4x plus 3y equals 5, and then I put it into y-intercept form. When you're trying to find the line that intersects something, so the slope is the negative inverse. So what I did was I figured out the slope was now 3/4, and therefore I created the equation for my perpendicular line is y equals 3/4 x plus b. Well, to figure out what b is, we know one point on the line, which is 2k. So I took and I figured out that if we take that, then k becomes 3/4 times 2 plus b to be on the line. So I then took k minus 3/2 equals b. So now I know what my intercept point is, the y-intercept of the new line in terms of k. So what I can then do is solve in terms of y, x and y. So if we take, we have our equation here in y-intercept form. Now we know that the x's intersect by setting the two x's, the two equations equal to each other. When I do that and I solve for x, I get x equals 12 minus 25k plus 38 over 25. Well, now I need to solve for y. So if I take this and I plug it in to another formula, I get my answer for what y is. So now I have my x and my y values still in terms of k. Well, I know the length of my line is 12. So if we use the Pythagorean theorem, I have 144 equals the distance formula. So if I subtract x1 minus x2 plus y1 minus y2, each of those squared, I can then solve for x. So if I do a lot of other work here to solve for x, I get this quadratic equation here. Well, I don't feel like trying to factor this, so I plugged it into the quadratic formula, which I didn't fully write out here. I get this answer of 18.35. So the next step, what I should do is then plug this in to the 2k and see if that seems reasonable. So based on what I can see, it seems like a fairly reasonable answer, but I'm not 100% sure. I'd suggest working through the math yourself again and see if that works. Hopefully this helps.